Hello and welcome to this recording on configuring a failover hypersec VPN between a Sophos XG firewall and an AWS VPC. So just a quick disclaimer before going ahead. So this is not a deep dive video into the Sophos XG firewall technologies. It's also not a deep dive video into AWS and the concepts of networking around AWS. This is mainly a configuration video. My main aim in making this video is to demonstrate how we can connect on-premises resources that are behind a Sophos XG firewall um, to resources that are located within our Amazon VPCs. So many organizations are moving more towards the hybrid approach in their move to cloud computing. And this is where some services are hosted on premises and where some services are hosted on the public cloud. But then there must be a way to have connectivity between those services. Maybe there are services hosted on premises that rely on some services hosted within your public cloud space. Or maybe there are services you're hosting on the public cloud that relies on services that you're hosting on premises. So you must have a way to be able to connect them. So today I'll be showing you how to do that with the Sophos XG firewall. And a quick introduction to the architecture that I'll be working with today. Let's get rid of that. So as you can see here, I have a very simple architecture, not to make things complicated. Very simple architecture in that I've got an on-premise site here where I have the Sophos XG firewall and I have a simple network behind it and it's got a public IP address. This is a very important part of this configuration is that your Sophos XG firewall on premises must have a public IP address, not a private IP address. So, and then on the AWS side, I have an equally simple architecture where I've got a single Amazon VPC where I have the CIDR range of 10.10.0.0/16. And then within that, I have a single subnet where I've separated that into 10.10.1.0/24. You can see I'll be deploying an EC2 instance within this subnet, and that's the IP address that I'll be giving it. So all this configuration, or what we'll be doing to make this connection happen, I'll be doing them from scratch so we can all see all the steps that are necessary to make this configuration to work. So the other thing that I would like to show you is I'd like to show you the steps that I wrote down here um, as to what the main steps that we'll have to follow to get this to work. So first we'll start by setting up the AWS side of things. Then next, I'll continue by setting up the side of the on-premises, which is the Sophos XG side of things. Then we'll move ahead to test our traffic flow, and then we'll move ahead to test our failover. So another point that I want to mention is this is going to be a redundant connection that we'll be making. So something that will fail over if one of the IPsec tunnels fails, it will fail over to the other one. So this will be a failover VPN that we will be configuring. So it's something that will be really nice. Another thing that I want to mention is that there's the way to actually do this on the Sophos UTM is a really nice and cool way. I'll be putting a description in the video below. So if you have the Sophos UTM and that's what you're attempting to do, there's a video on the Sophos YouTube channel that covers this very well. Very good video. I've referred to it a lot of times myself also. So I'll put the link in the description below if you're looking to configure the Sophos UTM. It does it in a really cool easy way. But in this particular video, it's about the Sophos XG and AWS. Okay, let's jump on and do the first one. So first, I'll do the AWS side if I bring up the notes. So let's bring up AWS. So the very first thing I'll do is, as I've mentioned in the note here, is I'll be creating an AWS VPC and a subnet. So let's go do that. And I'll be creating them just following this architecture. So I'll create a VPC in this range and create a subnet. Let's go ahead and do this. So I go under my VPCs, I create a new VPC, I'll call it DO AWS VPC. And the side range will be 10.10.0.0/16 as we have in a diagram. And I'll just leave this the way they are. I'm not going to be using IPv6. So from the last one I read is that we can't use IPv6 across between an AWS VPC and on-prem, in other words, across an IPsec VPN. So that's not supported yet. But if you want to use IPv6 within your AWS VPC, you can. But in this case, I'll just leave that to no, and I'll click yes, create. And that shouldn't take long to create, and that's done. Now we have a VPC. So the very next thing I'll try to do is I'll create a subnet within that VPC. So I'll call this DO AWS VPC subnet 1. And I'll link this to the VPC that I created earlier, which I can see here, the DO AWS VPC. And I can select an availability zone here. So one of the main differences between AWS, the approach that AWS takes or the Amazon takes and the approach that Microsoft takes with Azure is when we're talking about regions in Azure, we can't necessarily select which data center our resource are going to be living within an Azure region. But with AWS, we can with the concept of availability zones where we could go and select we want our resource to be living in this particular data center. So I'll just go ahead and select this availability zone, and I'll give it 10.10.1.0/24, and I'll just confirm that that's what I have here. Yep, 10.10.1.0/24. And let's create this. And again, that should not take very long to create. That should be done quickly. So the next thing that we'll do is I'll just quickly deploy an EC2 instance, just a small Amazon Linux instance into this VPC. So that's all done. I'll go under EC2, and what I'll do is I'll launch a new instance. I'll select the Amazon Linux. I'll just create something really basic. So I'll deploy this into my VPC that I created earlier. I'll select that option, and then I'll select the option for the subnet. I only have one, so that's the only option I get. And even though this IP address will be given out from the AWS fabric itself, what I'll just do is I'll make it kind of like a static IP. The IP address that I've designated here, which is 10.10.1.145. So I'll give it 10.10.1.145, and I'll go review the storage. I won't be making any changes here. I won't be making any changes to the tags. Security group, I will be making some changes. So I can see by default, because it's a Linux instance, SSH is allowed. But I also want to allow ICMP also. So I'll say all ICMP, allow from any. So let's leave that. So I can do some ping tests, and then I'll review, and then I can launch this instance. So I have to select my private public key pair. If I don't have any existing one, I can create a new key pair and download the private key. But in this instance, I have one already, which is my AWS public key pair. So I'll leave that. I'll acknowledge that I have the private key for that, and I'll launch my instance. So while that is launching, I'll go ahead to the next step. So the next step is I'll create something called VGW, a virtual private gateway. I'll create a VGW, and I'll connect it to the VPC. So back to our diagram here, a VGW is this one. So it's kind of like the VPN endpoint, so to speak, that will be creating an IPsec tunnel to or with. So we'll have to create it, this VGW, Virtual Private Gateway, and then we'll have to link it to the VPC. So what I'll be doing now is, let's create it first of all. Back to this. That's on the VPC. If I go down here, I can see Virtual Private Gateways. I can click on that and I can click create virtual private gateway. I give it a name. I call it DO AWS VPC VGW, and I'll create that. And that's very quick also. So that's created, but you can see here it says detached. So the next thing that I'll do in this case is I will be linking this VPC to this VGW. So that's the very next step that I'll be doing. I'm trying to get this straight. The benefits of using Paint. I'm really looking forward to using the new version of Paint in the Windows 10 Creators version. That'll be fun. So the next thing I'll be doing is creating this link. So that's a really, really simple step to do in AWS also. So to do that, I'll just click here, select my virtual private gateway and click attach to VPC and then select my VPC. And then I attach it. That shouldn't take long also. And that should be done very soon. So I've done this. So I've mentioned here configure routing or the route table. I'll probably come back to this. I'll show you what I mean by this. So the next thing is let me go ahead and create this thing called the CGW or the customer gateway. Now the customer gateway, in a sense, all it means is the public IP address of your Sophos XG firewall. So that or whatever address that your Sophos XG firewall will be using to initiate the IPsec connectivity with the Amazon VGW, that's what the connection gateway means in this case. So I'll just create a resource for that. So let's go back and I can find that on the customer gateway. So I have one that I created and deleted earlier. I'll just copy my IP address from that. Create customer gateway, give it a name. I'll call it my Oxford on-prem. Routing I'll set to static. If I want to use BGP, I can set it to dynamic and put in BGP ASN number and the IP address. But in this case, I'll just do static. The whole idea is that once you can at least understand the basics of getting this to work, then you can build on that going forward. So I'll put in my IP address and I'll create the customer gateway. So that's what we've done on the AWS side. Again, is I've created this object for this resource for my public IP within AWS. And then what I'll now do is I'll create a connection between that VGW and the objects that I've created for my public IP on the XG side. So in other words, and that's not okay. Hopefully that's good now. Okay, so I go on the customer gateway. I've created the customer gateway. Let's go back to that. Okay, the next step is connect the VGW to the CGW using a VPN connection. So I'll go create a VPN connection and I'll call this DO AWS VPC to Oxford on-prem. And I'll select my virtual private gateway that I created earlier. Customer gateway, I can create a new one if I don't have an existing one, but I have an existing one, so I'll just select that. And here on the routing options, if you're using something like the Sophos UTM, you can select a dynamic option, and it's really, really simple to configure and set this up. And again, I'll put a video, very good video, and that's on the Sophos YouTube channel. I'll put it in the description below if you're using the Sophos UTM. It's a really, really good one to follow. But in this case, we'll be doing static routing. So I'll just put static routing there. So now I have to specify under here the IP or the IP address range of my on-premise network. So in that case, I have to specify my on-premise range, which is 192.168.0/16, the whole range. So I'll put this here, 192.168.0.0/16. It's my range, and I'll click yes, great. Now this may take a while to complete, so I'll just move on to the next step while this completes. So that's it for now for the AWS side. I'll come back to this routing table and I'll come back to this part. But for now, let's move on to the XG side. So for the XG side, very first thing that we'll do is we'll create an IPsec profile that we'll use for AWS. And I think actually I might have one created. So what I'll probably do is I'll probably delete the one that I have created so that you can just see me create it from scratch and see where I got the information that I used to create it from. So let's log into this. And after logging in, I'll go ahead and delete the existing one that I've created. Nope, I do not have an IP. Oh, actually, I do. I need to get rid of this first of all. Get rid of the existing one. And then I'll go on the IPsec profiles and I'll get rid of the existing profile that I've created. Get rid of those. And I'll just create one from scratch, show you where I get the information from. So what I'll do is I'll go under the UTM on the VPN and under IPsec profiles, and I'll click add, and I'll call this AWS profile. And to show you, this is still being configured, but I'll go ahead and do that, and then I'll show you where I got the information from. So number one thing is I'll disable compression. It's always a good idea to disable compression when dealing with cloud. At least in my own experience, I know that if you do this with Azure, you could get a situation where traffics are not being decompressed properly. So just in my own experience, I leave this switched off usually. This is completed now, so it's a good time to show you where I get the information from. So one of the things that I put on my next steps here is I put in download, read, and extract needed information from the generic configuration file. So what do I mean by that? So I've created this VPN connection on the AWS side. There's this option here to download configuration. If I click on this option to download configuration, I get different vendor configurations that I could download. One of the options that I can see here is the option called generic. So that's the one that I'll be downloading. So I'll download this generic option, and you can see it says vendor agnostics. In other words, no matter which vendor you're using, this is something that you could use to make this configuration work. So I'll click yes, I want to download that. And I'll go ahead and open this in Notepad++. No, 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 no. And again, I'll just go ahead and drag it and open it. Okay, so I've opened this in Notepad++ now. I'm not sure how large this is to you, but the main parts of this that I'll be using, let me see if there's a way for me to make this larger a bit. There's zoom tool. Yep, there is. Okay. So zoom says control. Okay, let's do that. Yeah, that's probably better. Okay, so one of the things that you can see here that this configuration file contains information that I need for my configuration on the Sophos XG side. Number one, it contains the pre-shared key that I'll be using. It contains the authentication algorithm for both phase 1 and phase 2. And you can see here also that it contains information about two tunnels. So it has IPsec tunnel number 1, and if I keep scrolling down, I'll see IPsec tunnel number 2. So again, I'll be configuring two tunnels on the XG side, and the information I'll be using for those are the information extracted directly from this file. So number one thing that I need to configure is the profile that I'll be using. You can see here that the phase 1 is SHA-1, encryption is AES-128, the lifetime is 28800. For phase 2, it's SHA-1, encryption is AES-128, the time is 3600. And you can see they both use the Firewall group 2 for PFS. And then if we keep scrolling down, you can see the option for dead peer detection. It says it's advisable or recommendation from AWS is to use 10 and retry of 3. So that's basically what I'll be using to configure my profile here. So let's go ahead and do that. So on the AWS profile, phase 1, I'll leave this set to main mode. So phase 1, AES-128 encryption, SHA-1 authentication, DH2, and the time is 28,800. I'll leave the others. I'll leave that peer detection, and I'll set this according to the recommendation, which is to 10. And the retry, the recommended retry is 3, which means that will make it 40 because 3 retry will be 30 seconds. So I'll leave that. Action will be to disconnect or to disconnect if the peer is unreachable. Phase 2, I'll set this to AES-128 authentication SHA-1, and I'll leave the PFS group as same as phase 1, which is DH2 basically. And the key lifetime is 3600, which is what it is already. So I'll save that, and that meets the configuration requirements that we got from the document. So the next thing is let's go on and configure the IPsec connection from the Sophos XG to AWS. So as mentioned, we're going to be configuring 2 tunnels. If I go back to my AWS side of things, if I go on the tunnel details, you can see I've got 2 IP addresses from AWS, and I'll be building tunnels to both of these 2. And then I'll let the XG basically manage the failover between them if one of them fails. So what I'll do here is I'll go add a new connection. I'll call this AWS tunnel 1. It's a site-to-site tunnel. I'll select the policy that I created earlier, and I'll be initiating, and then I'll select the pre-shared key that's in the document for the very first tunnel. So the pre-shared key is this one. So I'll copy that and I'll paste that in here. And then my endpoint, I select my public facing interface, and then the public IP for the first tunnel on the AWS side, I could either get directly from here, or I could get from the document that I downloaded earlier. If I keep scrolling down, I'll see that IP address here. So I could copy it from either of them. So I'll copy that, go back to the Sophos and put that IP address in. So now I've got to specify the local subnet. My local subnet, according to the architecture that I got here, is 192.168.0.0/16. So that's what I'll be selecting. So I'll go to add, and I'll select 192.168.0.0/16, and I'll save that. And then for the remote network on the AWS side, that's 10.10.0.0/16. So I'll select that also. So 10.10.0.0/16, select that, apply, and that's done for the first tunnel. So I'll go ahead and save that. And then I'll basically follow the same steps to configure the second tunnel. So at this point, I won't be enabling any one of them. So I'll go ahead and click add. And I'll call this AWS tunnel 2. And then connection type is site to site. The policy, I'll select the same policy, initiate pre-shared key, and the pre-shared key for the second tunnel will be different. So I have to scroll down to the IPsec tunnel 2 and copy the pre-shared key for that second tunnel. So select the local public facing interface on the XG, and I need the IP address also of the second endpoint. So let's put that in there. Actually, there's an easier way to do this, but I already missed it now. I'll show you the easier way. Select my local LAN. and select my remote LAN. So local LAN is that, remote LAN is this, and I'll save it. The easier way for me to do what I just did for the second one would be to just clone the original one and just change the pre-shared key and the public IP, and that will have been much faster than what I did. So just so you know that the XG has that option for you to clone a connection if you need to, and then make changes to create a new connection. Okay, so I have this two that are ready now. Let's go back to our document. So I've configured phase one, I've configured phase two also. I've configured the two IPsec connections. Our side has to be the initiating side. AWS won't initiate to us, so that's important. I'll configure and enable a VPN failover group is the next thing that I'll do. But just before I go ahead and configure the VPN failover group, sometimes if you want to, you could just test to see if this tunnel will come up. You could click connect here, and let's see what happens. Yeah, and the tunnel did come up. So the tunnel is up now. Okay. So to create a failover group, I can see this option down here called VPN under, you see failover group here. I can go ahead and add a failover group. I can call this AWS VPN group and select my two tunnels because they both go into the same remote network. So they're redundant tunnels. So I'll select both of them and add them into a group. If I wanted to, the XG could actually send you mail notifications if there's any event that takes place with this group. So maybe a tunnel goes down, a tunnel goes up. If you select this option for mail notification, the XG will actually send you an email to notify you, or send an email to an IP address if you want to take some sort of an action to investigate if there was an issue. And here you can configure the failover conditions, which you can specify if something cannot be reached on the other hand. And so it's an um, if it's an if and configuration. If something cannot be reached on the other hand, and this other thing cannot be reached also. So that gives you like two layers of checking. So in case you've got like maybe an unstable connection that just sometimes drops or so, for whatever reason, you can make the checks not based on just one thing, but based on two conditions. So you can do a check based on two conditions. So I'll just select to ping the other side basically because it's just a demonstration. You could also be checking for certain TCP ports if you wanted to, but in this case I will just say ping and ping the other side, which is basically the same thing. And if you can ping the other side, I want you to shift to the next active connection. In other words, assume that that tunnel has failed. So I'll go ahead and save that. And I should have my VPN group created now. So I didn't have to enable this earlier. I could have left this disabled. So now that I have this created, the next thing that I have to do is I have to enable the VPN failover group. And then once I enable the VPN failover group, so basically the group now, it's managing these two tunnels. So the group is constantly monitoring for that this tunnel is active. If this tunnel fails, the group will take charge of that and move it to the next tunnel and try to make that connection. Okay, so let's move back to our notes really quickly. So create the firewall rules to allow access. Like many things on the Sophos XG firewall, you have to have your firewall rules in place. So I think I currently have two in place. I've got a rule for LAN to AWS, which you can see the source is from LAN and any host on the LAN. You don't have to do this. Probably it's not advisable for you to do this security wise. It's advisable to basically give least privilege. So only the networks that you actually want to be able to talk is what you're allowing. But in this case, it's just a quick demonstration to show you how it works, which is why I've not followed that principle strictly. So you can see I'm going from LAN to any host, and destination is from VPN to destination VPN, any host on the VPN, and the same thing in the reverse, anything from VPN to LAN, any host, any service. So that covers this. So I've got those two rules. And then the other thing now is that I can start testing and traffic flow. So for me to start testing traffic flow, So one of the things that I need to, so let's bring that up. I think there's something, okay, yeah, before I go ahead, something that I've missed. Um, so before going on to do the testing, I've missed something here. So this option that I said I'll come back to, configure routing or the route table. So what we need to do, this is one of the areas to be careful of, is when we created a subnet, it automatically created a route table for us. And you can see this route table by default is just routing the local subnet traffic. Anything 10.10.0.0 or the local VPC traffic, anything 10.10.0.0/16 routes them locally, right? Um, but this VPC has no idea how to reach 192.168.0.0/16. If I were using the other option that I mentioned that we could configure with the Sophos UTM, which is the option with BGP, I could actually use BGP to advertise the different networks and the different sites into one another, and they'll be sharing advertisements using BGP. But in this case, I have to configure it locally. So what I'll do is I'll go on the routing here and I'll edit this route table, and maybe not over here. I think let me go directly under the root table to do the edit, not under the subnet. So go under the root table, locate the root table that allow attached to your VPC, which in my own case is this VPC, and that's my routing table. I go on the roots, I go on the edit, and then I can select add another root. Then I can say 192.168 .0.0/16. The target is to my virtual gateway. In other words, what I'm doing is this. What I'm trying to say is I'm configuring this root table on here to say, or on here, to say anything that's going to 192.168.0.0/16, just send it over to this gateway, because this gateway has connectivity to this on-prem network and will take care of that traffic. So that's what I'm basically doing with that root table modification, just to uh, actually show what we've configured so far. This is what we've configured. These two IPsec tunnels. This is what we've configured so far. Okay, so let's go back now. Let's go back. So I have that, and then I save that. So now this root, or sorry, this VPC will know how to reach the other end. So the other thing that I'll actually do is I'll actually start doing the testing now. So if I do ping 10.10.1.145, what I'll try to do is I'll try to ping all the way from my laptop over here to this Amazon EC2 instance here. So let's see if that works. Let's bring up the command line. And if I do a ping for them, and yeah, I can ping it. So not only can I ping it, because my network or my security group, sometimes I mistake it, my security group on the side of AWS also allows SSH. So I should be able to SSH directly to it. So if I go 10.10.1.145, I go to select my private key, and I click open. It's opened up here. So you did that, yeah. So I'll click yes to that, and I have the prompt to log in. And I can log in as EC2 user and put in the passphrase for my private key. And now I'm logged into that. So that's all really nice. So I'm just connecting over this tunnel, and now my on-premises resources or services can access services on my AWS side, which is really, really nice. So that's hybrid cloud computing. The next thing I would like to demonstrate to you is to do a quick demonstration of what happens in case there's a failover. What happens if this particular tunnel, which is what we're using, actually goes down? What is it that will happen? So to demonstrate that, I will actually simulate a failure, which I've put here. So I actually simulate a failure of the first IPsec tunnel, and then I've verified that the other IPsec tunnel took over. So what I'll do is I'll bring up my command prompt and I'll do a continuous ping to the other end. So I'm doing the continuous ping now. I don't want it to be large. I want to reduce it a bit so that I'll just stop it and then do it again. Yeah, here we go. So I'm doing that, and then what I'll do is I'll bring up PuTTY and actually do a PuTTY session to my Sophos firewall. 192.168.0.254 is the IP address of my Sophos firewall. And I'll log in. So what I'll do is I'll actually run a command to simulate the failure of this first IPsec tunnel. Before I do that, let me show you the current state of things. So let's go back to the Sophos firewall. If I go back on the VPN, you can see that I have AWS tunnel 1 has been the active one. AWS tunnel 1 is the active one. So what I'll do in that sense is I'll simulate a failure of AWS tunnel 1 and see if this fails over to AWS tunnel 2 and see actually what sort of traffic do I lose. So to simulate that failure, I'll go under here and I'll just create sort of like a fake NAT. So if I do set advanced firewall, this is traffic NAT, add destination, and what I'll do again is I'll go to the AWS side of things and I'll go under my VPN connections. You can see the tunnel that's up, this first one. I want to take the IP address. I basically want to confuse the routing a bit. I'll confuse the traffic flow. S-night IP 13.13.13.13. So I want to confuse that a bit and then see what happens. So let me make sure I have the right and then run that. And let's see what happens. We're doing a continuous ping, still going. Still going. And while that's going, I'll go bring up my AWS, see if anything has happened. So maybe I've not managed to show so maybe that didn't cause the failure. I need to think of a better way to cause the failure there. Destination. I need to think of a better way to cause the failure. 1 minute. Oh, actually, I didn't need to think of a better way to cause the failure. So that eventually caused the failure. And as you can see here, I only lost a single ping. So I only lost a single ping here. And traffic just went on flowing. And I can show you that by if I go back to my Sophos and I refresh this. Now AWS2 is the active one and AWS tunnel 1 is the one that I've caused to fail. So what happens if AWS tunnel 1 comes back up? What happens is it will fail back. So if I go back and take the artificial failure off, so the ping is still going, but now the artificial failure that I did, let's take that out. Let's do remove that so that the other tunnel actually comes back up. Yep, and there you go, it failed back. There you can see it's only lost a single ping and it failed right back. And the way to see that, if I go back to my Sophos, again refresh that, and I can see it's failed back to AWS tunnel 1. And then I can keep doing the same thing to test failover. So that's basically it in a nutshell. It's a really, really nice one to know, and to have, especially if your organization has the Sophos XG on-prem and you have resources that you want to be able to share, that you want to be able to talk to one another on premises and in AWS VPC. So that's it for my demonstration today. If you have other ideas or other things that you maybe need some information about regarding the Sophos XG firewall and different cloud technologies out there, the AWS and Azure and even Google Cloud, let me know in the description below, sorry, in the comment section below. I'll put the links that I mentioned at the beginning of this video in the description below also. So thanks very much for watching this video, and I'll see you in my next demonstration. See you.